Piecewise functions are defined by multiple subfunctions, and each subfunction is defined over a specific interval or certain portion of the domain of the main function. So in this example, we have a piecewise function f of x here. We're given the equation, and then we're also given the curve. And we want to kind of examine how the curve relates to the actual function itself. So if we're looking at this first portion here, x squared minus 1 for x less than 2, that's telling us that when the values of x are less than 2, so if we're looking to the left of 2, our graph itself is defined by this parabola. So you can see that this quadratic is shifted down 1, and it's only being graphed for x values that are less than 2. So for all values of x less than 2, the first function, x squared minus 1, is the graph that we use. So for the second portion, in here, f of x equals 1 when x equals 2. So it equals 1 when x equals 2. Now this is an interesting one because normally when you have f of x equals 1 or y equals 1, that gives us a horizontal line. It says that for every x value, the y value is just this number. But in this specific case, we're just talking about when x equals 2. So at one singular x value, the y value is 2. So when x is 2, the value of our function is 1. And as a result, what that does is it gives us just a single point, right? So when x is 2, the y value is 1. So singular point of 2, 1, right? The x value is 2, the y value is 1. And that's because it's only being defined there when x is equal to 2. And then the last one, the last piece that we use is for x values greater than 2, right? For x values greater than 2, we get this definition there, negative 2x plus 8. And that's going to be this line that we have here. So negative 2x plus 8 is defined for this last portion. And you can see that this function is defined on the whole real number line, right? So all values less than 2, all values greater than 2, and at 2. Now, because this is a function, piecewise function, our function has to pass the vertical line test. So it should pass the vertical line test. So that means that you need to be careful when looking at these domains that your curves don't overlap, right? Your curves don't overlap. So they're only defined for specific portions of this domain. So you can see that our quadratic is only for x values less than 2. Our linear is only for x values greater than 2, and then we have that point there. Now in this portion here at x equals 2, right, it might look like we have some points that overlap, but because these are open, right, that means that our function is not actually defined there. It doesn't actually reach that point, and this is the only output that actually comes from the input of 2.